Uh, okay. Dear participants, today I'm going to start the topic correlation. Oh, okay. So basically, correlation it is a association between the two variable. Correlation means association. More precisely, it is measure of the extent to which two variables related. Okay. Therefore, when one variable increases as other variable decreases, or one variable decreases while the other decreases, and its value between -1 to +1. Basically, correlation it is a association between the two variable, and we check the association between the two variable by changing the one variable. When one variable change, it means when one variable, if we increase the one variable, then we see the impact or association on the other variable, whether it is decreasing or increasing. Okay. So here we can see there are three types of correlation. One is positive correlation, negative correlation, and no correlation. When we study the variables, so here the variable means, like now you can see in the small diagram I am drawing here. So this is y axis and this one is x axis. Okay. So this for example, it is price, and another y axis we can take another variable sales. Now we want to see the relationship between the price and sales. So it means this is the price of the commodity, 10 rupees, 15 rupees, 20 rupees. As we increase the price of the commodity, the sale will decrease. It means for price 10 rupees, the sale of the product, this is 100. Okay. If we increase the price, then the sale of the product decrease, and then again if we increase the price of the commodity, then it decrease. So this is a negative relationship between the two variables. Another type of the correlation, that is positive correlation. In a positive correlation like this there are two axes, one x axis and another y axis. Okay. So when we increase the x variable, okay, like this is the discount, and another variable y sales, then 10% discount, 20% discount, 30%. When we give the 10% discount, for example, the sale would be 50 unit. When we increase the discount 20%, then sale would be 80, or, and when we give the discount 30, then sale would be higher. So here there is a positive relationship, positive association between the two variable, discount and sales. This relationship known as positive correlation. Okay. And third, there is no correlation. For yeah, now the x-axis and y-axis, and this is the sales on y-axis, and I can take the x-axis like temperature. Okay. It's a hypothetical example. If the temperature increases, there is no relationship between the two variables. It means there is no correlation, no relation between the two variables. And one more thing we should keep in mind, the value of the correlation always between -1 to +1. It cannot go beyond the limit. and it means if value of the uh, two variables means r coefficient of correlation uh, plus 1, it means it is perfectly positive correlated. Perfectly positive correlated. This positive sign means when increase the independent variable, dependent variable increase. Okay, there is a positive correlation between the two variable. This is the strong correlation, and you can take point 0.9, point 0.8. It is the strong correlation. And medium correlation means if its value 0.6 to 0.3, it is medium. And low correlation means minus sorry 0.3 to 0. 0 means no correlation. Same as we can take the negative correlation between the two variable, r equal to minus 1. Minus 1 means perfectly negative correlation between the two variable. And if I take value minus zero point 0.9 or minus zero point 0.8, it is strong, high correlation, high, negatively high correlation, negatively high correlation. And minus zero point 0.6 to minus zero point 0.3, medium, negative medium correlation. And if it is minus zero point 0.3 to 0, it is low, negative low correlation. Okay, so there are the correlation means association between the two variable. Now we can take the example of positive correlation, that is height and weight. Okay, bivariate correlation. So bivariate correlation, there are two types of correlation. One is bivariate correlation, and second is partial correlation. So first of all, we should understand the difference between the bivariate and partial correlation. Okay, bivariate correlation is a correlation between the two variables. When we take two variable like price and sale, these are the two variables, and we want to find the relationship between the two variable, it is known as bivariate correlation. Now second is partial correlation. In a partial correlation, we take more than two variable and one variable controlled. For example, here I am taking the three variable in a bivariate, sorry, partial correlation. In a partial correlation, the one variable sales, another variable price, and third variable, that is discount. Okay, so in this example, if we control the discount and then find the relationship between the sales and price, then this relationship known as partial correlation. A partial correlation looks at the relationship between the two variable, means sales and price, while controlling the effect of one or more additional variable. Here I am adding one variable. Okay, so in case of bivariate, simply I will take only the two variable, one sales and price. But in case of partial correlation, I will take more than two variable, means three variable, four variable, five variable, and then check the relationship between the two variables. uh, the bivariate correlation. Now, how to find the bivariate correlation? So, example bivariate correlation, we find the bivariate correlation through Pearson product moment correlation, and second is Spearman's row correlation. So there are two methods to find the bivariate correlation. Then bivariate, the conditions of the bivariate correlation. The condition one is Pearson correlation coefficient. It means in a bivariate correlation, we take two variables and both the variables should be continuous. And the condition is data should be normally distributed. It's an assumption of parametric test. So before applying the bivariate correlation, we should check the assumptions of the parametric test, and our data should be normally distributed. Okay. And the continuous means the variable should be either interval scale or ratio scale. Okay, so both the variables should be in a continuous means either interval or ratio scale question. Second is the bivariate correlation. The bivariate correlation, this is bivariate Pearson product moment. Yes. Second is the Spearman's correlation coefficient. It is non-parametric test. So before applying correlation, we should check whether our data parametric or non-parametric. If it is parametric, then we should go for product moment correlation coefficient. If it is not parametric data not normally distributed, then we should find Spearman's correlation coefficient. Here, both variables should be ordinal. It means we are taking two variables, y and x. Y means dependent and x means independent, and both the variables should be ordinal. Ordinal, there should be ordinal data. Okay, if my data is in a continuous and it is not normal, then we can convert our continuous data into ordinal, and then we can apply Spearman correlation coefficient. Okay. So the another is Kendall's tau. It is same method. It is same the Spearman correlation coefficient and the Kendall's tau method. Again, it is non-parametric test. This means that if you rank all of the score and many score have the same rank, then Kendall's tau should be used instead of Spearman coefficient. And another thing, it is appropriate for a small data set. So there are two conditions. One, if our scores are tied, it is okay, tied score rank hai, then we should go for Kendall's tau. And if my sample size is small, then again it is better to conduct a Kendall's tau in case of Spearman coefficient. Okay. So next is by the Kendall's tau method. Both variables should be ordinal. The condition is data should be non-normally distributed. It means if our data not normally distributed, then we should check correlation by using Kendall's tau method, and it will convert continuous data into ordinal automatically in SPSS. Then another point, the correlation that is biserial and biserial point and biserial correlations. So in a biserial correlation, these correlations are used when one variable these correlation coefficient are used when one of the two variable is dichotomous, that is it is categorical, okay, with only two categories. So basically there are three conditions we can see here. One is continuous data. For continuous data, now the one is here the in this case the y equal to continuous and x is categorical. Categorical means nominal scale, two categories, just yes or no, or male or female, male or female. It is categorical data. So here we are using three types of data. One is continuous. Continuous means interval or ratio. And second is categorical. Categorical nominal and other ordinal. Okay. So it is depend on the type of data. If my data both the variables continuous, then I should go for a product moment correlation. If my data ordinal, then the I will use Spearman's correlation row. Okay. Now, the continuous biserial and point biserial correlation. What does it mean? Here, the categorical data, X is categorical data. These correlation coefficient are used when one of the two variable is dichotomous. It is categorical with only two categories. Condition is only two categories. Then we can apply this. And then the point biserial coefficient and the biserial coefficient. Now question is, what is the difference between the point biserial coefficient and another biserial coefficient? Okay. Now the difference is when one variable is discrete. Discrete is mean completely mutually exclusive. Discrete means dead or alive, yes, no, male, female. Then it is known as point biserial correlation coefficient, and we find the correlation between the two variable by using Pearson correlation. Okay. And the biserial coefficient is used when one variable is continuous dichotomy, that is passing or failing. It means it is not clear cut difference between the pass and fail, because it is a continuum. It means you can fail by only one number, two number. So it cannot, so it is not completely mutually exclusive. Okay. So here the biserial correlation coefficient cannot be calculated directly as PSS. So there is some equations. So by using these equations, we can find the serial correlation coefficient. And next is partial coefficient. I told you there are two types of correlation. Initially, the bivariate correlation and partial correlation. So I have discussed about the bivariate correlation. Now I am discussing partial correlation. In the partial correlation is the measure of association between two variables while controlling or adjusting the effect of one or more additional variable. Okay. Then we can check the impact of individual variables on dependent variable. For example, in case of multiple regression analysis, you can see this equation b1 x1, b2 x2, b3 x3, b4 x4, and so on. Okay. And so on. Now, if we want to check the correlation between the x1 and y, then and controlling the effect of all the three or more variables, then the correlation between the y and x known as partial correlation. Okay. If I want to check the correlation between the x2 and y and control the three variables, then this is known as partial correlation coefficient. Okay. Now this is the type of partial correlation coefficient. And in a partial correlation can be used in many cases that assess for a relationship, like whether or not the sale value of a particular commodity is related to expenditure on advertising when the effect of price is control. Okay. So here we are taking three variables. One is sale, then advertising expenses and price. Okay. And we are controlling the price variable, and want to check the relationship between sale and advertising expenses. Okay, so now I am taking example of each, means I will explain now the bivariate correlation, partial correlation with example. Okay, so first of all I will take example of uh, Pearson product moment correlation, then Spearman's law, Kendall's tau, Biserial, and uh, the another partial correlation. Now I am stopping this slide and sharing the SPSS, how to do in a SPSS. Negative correlation. Okay, one question, what is negative correlation? Okay, I am explaining uh, negative question, negative relationship. Negative, I explain negative correlation. Yes. Now, negative correlation means the relationship between the two variables. You can see there this graph, the y-axis and x-axis. Okay, so I am taking the satisfaction. Satisfaction, yeah, or sale of the commodity. It is very simple example, sales, and x is price. Price of petrol also. So generally, if the product cost is uh, 100 rupees, okay, the sale of this product 10 units, 10 units, okay, then so and this is variable. Okay, now if I reduce the cost of the product, means 100 to 50 rupees, then naturally sale will increase. So the sale is increased. Now it was 10, now this is 100. Now sale increase, so this is, if I again reduce the price of the commodity, again the sale will increase. So here we can see the positive, sorry, negative correlation. This is the negative correlation. It means it is the inverse. When we decrease one variable, other variable increase. When we increase one variable, other variable decrease. Okay. Now I am taking the example of correlation coefficient. So my first Pearson, I am sharing this slide. Okay, you can see this slide. So in this case study, you can see there are four variable: one revision time, exam performance, and tension or anxiety. We can say anxiety. Okay. So in this case study, we want to find the relationship between the revision time, exam, and exam performance, and tension, and both for male and female students. Okay, so in this case study, we have taken data of 100 participants. Here 100 participants. Okay, now you can see the three variable: revision time, exam performance, and tension. So exam performance, that is, you can see here the what is the relationship between the exam performance and revision time. Okay, so now you can see the exam performance. It is same as here. Now this is, I am making the graph. This is, now you can see this y variable, exam performance, ep, exam performance, and x means revision time. So I think there would be positive correlation between the revision time and exam performance. If you contribute or devote more time to study, then exam performance will be better. If you are devoting only 1 or 2 hour, your performance would be this. If you are devoting more time in your study, definitely your performance would be high. So there would be positive correlation. And another variable I am taking in this study, that is tension. If you are in a more tension is more, it means anxiety, high anxiety or tension, uh, this. So this is a tension. If you are less tension, then your performance would be high. If you are in a more tension, if the value of tension is high, then your performance may be decreased. So there is a negative correlation between the two variables. So in this example, we will find the positive and negative correlation both, and through analysis we can see this. Now I am applying the correlation coefficient. So first of all, analyze and then correlate. You can see correlate. Is it clear? Then there are three things: bivariate, partial, and distances. So we will use only two terms here, one bivariate and another partial in our correlation. So here bivariate, bivariate. So I am just ticking bivariate. This is bivariate. Now bivariate, I will this all the three variables. I am selecting all the three variables. We want to see the association between the three variables: revision time, exam performance, exam tension. Okay. So I am just selecting all the three and transfer in a variable box. And then by default it is Pearson. We need Pearson correlation coefficient. Okay, so we do not need to do anything, and just uh, okay. So here you can see two-tailed and flag significant correlation, and here I am ticking okay, and after okay we can see the result. Now I am stopping this slide and showing you the output. So output, I am sharing the output of, I think you can see the output. So output here. So there are three variables: revision time and exam performance. It means its value is 0.366. It means it's a positive correlation. The revision time and exam performance, it means you do devote more time on revision or your studies, then your performance will increase. And then another relationship, revision time and exam tension, it is negative relationship. This negative relationship tell us the, if you are in a high tension, then your performance will decrease. Okay. So and revision time, if I find the relationship between revision time and exam tension, if you are more time, you are more tense, then you will not give the uh, time to revise your subject. If you are less tension, if, then you will give more time to your revision. Same as you can see exam tension and exam performance, it is minus 0.450. Exam performance again negatively correlated with exam tension, and the value is minus 0.45. Okay. So same thing we can see through the graph also. So I am preparing the graph. So is graphs chart builder, and the slide you can see here correlation, and the simple graph. So this is the two variables: revision time and exam performance. This is exam performance and revision time. Okay, revision time and exam performance, and then close it and okay. And after okay, you can see the graph. I think you can see this graph. This is the positive correlation between the two variables elements, and I want to draw the line, fit line at total, so you can see the graph. I think it is visible to you. Again, I can show you this graph. I am sharing the slide. This. Okay, so this is the graph. So exam performance and revision time. Revision time means as revision time increases, your performance also increase, and this is the positive correlation between the two variable. And another that is the negative correlation. Example of negative correlation, the exam performance and exam tension. Now you can see this graph. This There is negative correlation between the two variables. Now I am stop sharing it and sharing the output. This, I think it is visible. So there is a negative relationship between the two variables. Okay, exam performance and exam tension. If you are less tense, then your performance would be high. If you are high in tension, then your performance would be negative. Now another type. So how to interpret this result? Now you can see here. So this is the negative correlation between the two variables. Minus point, how to interpret it? Now question is how to interpret this result. So the correlation between the, you can see exam tension and exam performance, this is negative correlation. So this negative correlation means negative relationship between the two. But now for interpretation purpose, we use coefficient of determination, means R square. R square is coefficient of determination. So we will interpret through this R square, and it means if we square of this, square of minus 0.45, this. So what is the value of R square? So here R square value is 20.25%. What does it mean 20.25%? It means these two variables are negatively correlated, and this particular variable means exam tension. This exam tension tell us how much of the variability in exam performance is shared by this variable. It means this is the exam performance variability 20.25% due to the exam tension. It means we can say the, it means 79 point, means if subtract 100, then it means 79.75% of the variability is still to be accounted for by other variables. It means other variables also influence the exam performance. Only this exam tension 20.25% vary to the exam performance. Okay, so we will interpret this way. And now I am taking the another example, Spearman correlation coefficient. I am opening the another slide. Spearman, the second example. This is my second example. Okay. Now in this case study, there are two variables. One is competition and another is rank. Okay. So here the less rank, it's a data of 10 years. It means the one company organizing competition and last 10 years. Okay, in the, so this is the data of 10 years data. This is year one data and year two data. So same as we have 50 observation. Okay, 10 competition had last 10 years. So here in a particular competition, the rank means the person who obtained the high marks, and rank 5 means person who obtained the least mark in the competition. So there is a negative, we can see the low number does not means poor rank. Low number means good position, and rank 5 means poor performance. Okay, so here the both the data, this rank basically it is a ordinal scale data, and the this is continuous, but if it is not normally distributed, then SPSS automatically convert this continuous data into ranking data. Okay, so we apply here Spearman correlation coefficient. How to conduct it? Because here the condition is both the variable ordinal scale variable. Okay, now we see the how to perform it. Analyze, then correlate and bivariate. Okay, analyze, correlate and bivariate, and then transfer both the questions, both the variables here, and then Spearman. I am taking here Spearman and untick Pearson. Okay, Spearman, and then OK. And after OK, I am showing you the output, stopping this and the output. Now you can see the output. So this is the output, minus 0.804, and competition and rank in competition. There is a negative correlation. So here the correlation coefficient between the two variable minus 0.805, and it is significant 2 star. You can see whether this correlation significant or not. If it is significant, it means there may be 2 star for this correlation significant at the 0.01 level. Okay, so here you can see it is a negatively correlation between the rank and competition. So and this relationship is negative. It means the the student perform in a competition and obtain the high marks, and its rank number is low. Rank number is low. It doesn't mean there is a negative relationship, but here in a ranking case it is different. Okay, so rank 1 means the performance is good, and if someone rank number is 5 or 10, it means performance low. So there is a case of the Spearman correlation coefficient, and same thing we can apply in the third method, Kendall's tau method again. But the in a Kendall tau method, I am taking the this example again, the Spearman Kendall, the same example I am using Kendall's tau method here. So the difference between the Spearman correlation coefficient and Kendall tau, the only difference is in a Kendall tau method, both the variable should be ordinal, but the only difference is the if our score tied score and sample size is less, means 20, 30, sample size is less, and some scores rank tied, then we use the Kendall's tau. So same example I can use the Kendall tau method. Then how to perform it? Analyze, correlate, bivariate. Okay, analyze, correlate, bivariate, and then untick spearman, tick only candle stove. Okay, candle stove. The condition is both the variables should be in a ordinal data, and then okay, and after okay we will get the result. I think you can see the result here. So in this result, the correlation between the competition and rank, this is minus 0.63, so minus 0.673. Okay, so its interpretation same as in the Spearman correlation coefficient. It means low number means high rank, and if someone rank number high, it means its performance low performance. So there is a negative correlation. Now I am taking the point biserial coefficient. Another example, I am stop sharing this slide, and I am taking the another slide that is related to point biserial. So point biserial, this is example of point biserial correlation. Okay, now you can see this slide. It's case study from the Andy Field book, Discovering of Statistics Through SPSS. Discover the title name of the book, Discovering of Statistics Through SPSS. It is very nice book. Every novice researcher should go through this particular book. So if you need this book, you can write me. You can send me your email ID, and I will share you this book. Okay. So all the examples I have taken from this book, Discovering of Statistics Through SPSS. Or for more detail, you can go through this book. It is very beautiful book. You can understand the concept very in a depth manner. You can understand. Okay, now the point biserial coefficient, I told you, in a point biserial coefficient, basically what does it mean, point biserial coefficient? In a point biserial coefficient, one variable continuous and another variable, this is categorical variable. The again explaining the concept of the point biserial correlation. The concept of point biserial correlation is this: there are two variable y and x. Okay, now I am using, so y and x. So y should be continuous, this should be continuous, and this particular variable categorical variable, it means nominal, and condition is only two category. Okay, so here category is gender. Gender means male and female. And this, in this case study, time means the person. So it's a case study of cats. Okay, male cats and female cats. So how many hours cat away from the home, the male cats and female cats. So we want to find the relationship between the two variable, that is the time, and whether male cats uh, devote more time outside the home or female cat. Okay, so this is example of the categorical, this male and female two category. The condition of the uh, point biserial correlation coefficient is there should be two category. Okay, and then we can apply the this point biserial correlation coefficient. Now, how to perform it? So we can see here, analyze and then correlate. and then bivariate. Okay, this is bivariate. Analyze, correlate, bivariate. Okay, now the time away from the home, this is continuous variable, and another variable, gender of the cat, I am transferring here. So both the variables. Okay, time away from home, gender of the cat, and simply for we should keep in mind when we are performing point by serial correlation, we tick Pearson correlation. Okay, same as for continuous data. So Pearson, and then okay, and we can see the output here. I am stopping and sharing the output. You can see the output. So here the output, you can see there is a the coefficient correlation by point by serial correlation coefficient value is 0.378. Okay, now when we square of this, because if for interpretation purpose we square the correlation, then if we square this correlation, then coefficient of determination value come 14.3%. 14.3%. It means the gender of the cat vary the time about away from the home 14.3%. Okay, now another example, I am taking the example of partial correlation. Partial correlation example. So partial, same partial correlation. This is the par. Okay. Now you can see the partial correlation. Now partial correlation, what does it mean? Partial correlation coefficient, as I earlier told you, the relationship between the two variable and controlling the other variables. Okay, now how to perform it? Analyze by basic opacity, where you are showing result. Explain the basics of SPSS, like where you are showing explain what is explained. Example, sir, not clear. You are explaining, Pran. Why, sir? Why this 0.01 level significance? Okay, so I will explain one by one your queries. Okay. Okay. Now, this is very simple case study I have used earlier. So here there are three variables: revision time, exam performance, and tension, and fourth variable, that is gender. So we want to find the partial correlation coefficient. Partial correlation coefficient. So how to perform it? Analyze, correlation, and partial. Okay, partial correlation. This is a partial correlation. So revision time. So exam performance. Okay, depend on exam tension. So I am taking two variable here: exam performance and exam transfer tension, sorry, and revision time. I am controlling the variable, that is revision time. Okay, we know that exam tension influence the exam performance, and the relationship between the two variable, it is negative. High tension, low performance. low tension, high performance. Okay. Now we added another variable. We are controlling the effect of revision time. Now we can see the exclusively contribution of exam tension on exam performance, controlling the effect of other variables. Now options, here we can see the options: zero order correlation. Okay, zero order I am taking here, zero order correlation, and then continue. Okay, and then okay. Now I am showing you the result. I am stop sharing this slide and sharing the slide output. This is output. Okay. So here there are two matrices. One, you can see the here none A, exam performance, exam tension, revision times. It is simply bivariate correlation among the three variables. Okay. So, and under this table, second, you can see here revision time, this, and exam performance, exam tension. This is our main table. Here you can see value in four cells: one, second minus 0.297, minus 0.297, and 1. Okay. Now, what is the difference? So, the difference is this particular table. So there are I can divide this output into two. One, this is this particular table, this one. It is simply bivariate correlation. Bivariate correlation. And this table, it is partial correlation. Now you can see when we do not include exam tension as a control variable, then the correlation between the exam performance and exam tension is this: R is point minus 0.450. Okay. And when I square this value, basically it is a variance, or we can say coefficient of determination. Coefficient, for interpretation purpose we use coefficient of determination, means R square. And what is this value? The value is 20.25. When we use partial correlation, then its value this, again I am repeating, you can see the its value, this is minus 0.297, and without controlling the value is R equal to minus 0.450, and R square equal to 20.25% variation due to exam tension on exam performance. Now here the for partial correlation, R value decrease minus 0.297, and R square value, when we square it, it comes near 7%. So this is when we do not control the variable, the R is the contribution of exam tension on exam performance 20.25%. But when we removed or control the effect of revision time, then the exclusively or unique contribution of exam tension decrease, and it is only the 7%. Now there are three or four types of situation. For example, in this if y sorry uh, this yes, draw. Mhm. Okay, I think some you you can see the yes, the I'm talking about the when it's a zero order. So there are some conditions in the y equal to, for example, this is my regression equation, b0 plus b1 x1 plus b2 x2. Okay, and this is exam performance, and this particular variable exam tension, and this variable x revision time. Okay, when we control one variable, okay, when we control one variable, it is known as first order first order partial partial correlation. First order partial correlation. For example, I am adding another variable b3x3 and controlling both the variable, then this type of correlation known as second order partial correlation. If I add another variable b4 x4 and controlling all the three variables, then it is known as three order partial correlation. Okay, so this is about the correlation, and there are some query. I am just looking your queries. Acha, now some question is how to one question, how to insert data in SPSS. So basically it is very basic question. So how to enter data, it is not related to this question. You can see my lecture video how to insert data in SPSS. So basically the I'm showing you the slide. So in a SPSS means this is there are two view, data view and variable view. Okay, so these are the questions, means question number 1, question 2, question 3, question 4. First of all, whatever questions, for example, in our questionnaire, 50 questionnaire questions there. Okay, so we will write the questions here, means revision. It's a we can write simply q1, q2, q3, q4 and so on, and full question we will write here in a label, and then we can uh, take the options here like 1 and 2 coding. Okay, so you can see my video how to enter data in a SPSS, because if I explain here it will take time how to enter the data. And your another query. Okay, so next is significance. Why is significance level 0.01? Okay, there are three types of significance level. One is 5%, 1% and 10%. Generally in our social sciences we take 5% significance level it means if in our population, if we take 100 sample, it means out of the 100 sample mean, means out of the 100 sample, we are taking 100 samples from the population, and out of the 100, 95 sample mean will come uh, under the this particular range. This means the lower tail 2.5% sample mean away from the lower tail, and 2.5% sample mean upper tail. So 95% sample mean will come under the confidence interval. Okay. So in science study, you can take 0.01, means 1% significance level for more accuracy. But in social science research, generally we take 5%. Okay. And then another question, biserial, I have explained. Biserial, yes. How to control the variables? So control variable means, for example, we want to check the relationship. Here there are four variables: revision, exam, tension, and gender. Okay. So we want to check the relationship between revision and exam performance. What is the relationship between the two? If we do not include tension, okay, then bivariate relationship would be different. And when we include the tension also in this equation, then and control the this variable, controlling means uh, we are not taking this variable into our study. Okay. So we want to see only the exclusive or uniquely contribution only this particular variable. So this is about the correlation coefficient. So uh, okay, again partial correlation coefficient, no problem. I am again explaining the partial correlation coefficient. So basically in a partial correlation coefficient, so this is my equation like this: y equal to b0 plus b1 x1 plus b2 x2 plus b3 x3, and so on. Okay. So there are three types correlation. One is simple bivariate, means zero order correlation. When we take zero order correlation, simple bivariate correlation, then uh, our value may be, for example, the relationship between the two, it is 0.45 positively. Okay. It means this particular variable contributing to the means association, the positive correlation. And when we square of this about 20%, it means this particular individual variable vary this outcome variable 20%, and rest of the variable may vary this outcome variable also. Okay. Now if I want to check the partial correlation, means uniquely of this particular variable, then I will control the effect of these variable. I am not taking consideration these independent variables, and here I am checking the impact unique contribution of this independent variable, this. So it is collectively, when we are taking all the variables simultaneously in our study, then contribution of this variable is 20%. When I remove the impact of these variables, then contribution may be unique 7%. Okay. If you want to know more about the correlation, then you can go through the book Discovering of Statistics through SPSS. So you can do this. Now I am starting the correlation, the next question above. I am taking another topic, that is bivariate correlation, or so I am explaining first through the PPT, and then I will take the example of this next question. Why significance two-tailed value in bivariate? Okay, so you can take a bivariate correlation. So it is your it's your choice ki whether you take the one single test, means one tail or two tail. Okay, so one tail or two tail study, if we take the two tail, then we can check the significance level of either 0.05 and 0.01. So it depend on the objective of basically there are three types of uh, hypothesis you develop. One is one tailed, two tailed, and another means either one or two tailed, means directional or non directional. Okay, if you are taking the directional, so you can take 0.05. If you are taking the one directional, then you can take one tailed, or means left one tailed or right one tailed. Now multiple regression. No, so I am taking some slides of multiple regression analysis, and after these slides I will explain bivariate regression analysis, and another is mm, multiple regression analysis. So only very small difference between the bivariate regression analysis or simple regression analysis and multiple regression analysis. So here you can see y equal to b0 plus b1 x1. Okay, this is my equation. So it is simple, but simple regression analysis. It is simple regression analysis. When we take only the one independent variable and one dependent variable, it is known as simple regression analysis, or bivariate regression analysis. Multiple regression analysis means when we take more than two variables, like this is intercept b1 x1 plus b2 x2 plus b3 x3 plus b4 b4 x4, and so on. Okay, so here we are taking one dependent variable and several independent variables, and all the variables should be metric form. Metric means continuous data. Okay, so multiple regression, these are the independent variable x1 x2 x3 x4 and so on. So what is multiple regression analysis? Multiple regression analysis is a statistical technique that can be used to analyze the relationship a single dependent variable and several independent variables. The condition is, we should keep in mind, we can apply multiple regression analysis only when we have single dependent variable and several independent variables. So here it is single dependent variable and several independent variables. Now it is the decomposition of the total variation in regression. So here you can see the total decomposition of the total variation in regression. Now the total sum of a square here, total variation equal to residual variation and explained variation. There are two terms you are seeing here, the residual variation and explained. Okay. What's your query? Okay. Now, in this graph, you can see, so the total variation means this is equation, like my equation is y equal to b0 plus b1 x1 plus b2 x2 and so on. Okay, and this is error term. So here this is observation of individual observation, and this is the estimated value, and this is mean value. Okay, there are three values: individual observation value yi cap estimated value, y bar the mean value. Okay, now this is the in this particular regression equation, these two variables x1 and x2 are influencing the outcome variables. Okay, now the how much they vary to this outcome variables. If they both the variables are uh, explaining outcome variable 60% or vary it 60%, then 40%, this is unexplained part. This is 40% means another variable can explain the y. Okay, so residual, the difference, the this is observed variable and this is estimated. The difference between this, the difference between the observed and estimated should be less. This should be less, and the difference between the mean value and estimated should be high. Okay, so if I can draw this way, this is my yi and this is y cap and this is y bar. Okay, there are 3 points here. So in our model, this difference should be less. The distance between the two variables should be less in comparison to this. So if this, the difference, this is less, like yi, y cap, this is the residual, this is the error. So, and this is our model regression, this difference through the regression model, this. Okay, so we want this should be high and the error should be less. So we can divide total variation sum of y SSY. So S sum of square y equal to sum of square residual plus sum of square regression. So here the sorry. So oh, this again, yes. So the sum of square y, we can decompose into two parts. Residual means error plus explained variance. So this is the decomposition of the total variance, and we can see it through the, yes. So total variation, now you can see the total variation equal to explained variation plus residual variation. Residual means error term, and then we can write is sum of square y equal to sum of regression plus sum of residual. Okay, so how to find the sum of square y? This is the formula, summation of yi minus y bar ka whole square, sum of square regression equal to, then y I cap minus y bar का स्क्वायर एंड रेजिडुअल, इस तरीके से हम वी कैन फाइंड द रेजिडुअल बाय दिस फॉर्मूला. So there are three values. We are using three terms: yi, y bar, and y cap. Yi means value of individual observation, whatever we are giving to a particular question, and y cap means estimated or predicted value observation. Through formula we get the value, and y bar the average of all observations. Now, before applying any multiple regression analysis, there are 6 stages of performing the multiple regression analysis. Now, first of all, we should tell ourselves what are our objective. Okay. Then the first of all, we define the objectives. In the first step, we should define the objectives of the multiple regression analysis. And second, research design of multiple regression. Third, assumptions in multiple regression analysis. Fourth, estimating the regression model and assessing overall fit, interpreting the regression variate, and validation of the result. So before applying any multiple regression analysis, we should follow 6 stages of performing the multiple regression analysis. Okay. Now, what does it mean, the objectives of multiple regression analysis? Now question is, why should we use multiple regression analysis? What is the purpose of multiple regression analysis? So basically, there are two purposes of multiple regression analysis. Generally, we use multiple regression analysis for prediction purpose. Prediction. It means on the basis of data, we want to predict the future. Okay, what will happen in future? For example, I have trained score means time series data, means 10 years data, 1 year's data. So I want to, means I have data of last 1 year data, day wise sales of a particular retail outlet. Means day 1 the sale is 10 lakh, day 2 sale is 13 lakhs. So I have the last 1 year data, 365 observations, and on the, this is the time series data, and on the basis of this data we can predict what will be the sale in a particular month. On the basis of uh, last 12-month data, I can predict the what will be the sale after 4 months, 5 months, and so on. So the first purpose of the multiple regression is prediction. So we can use it in the cross-sectional data also, and we can check the impact of particular uh, particular variables on outcome variables. Okay. Now the second is explanation. The purpose of the multiple regression analysis means explanation. For example, in our multiple regression analysis, we have many variables, like one dependent variable and uh, other uh, this one outcome a criterion variable, and these are the independent variable: b1 x1, b2 x2, b3 x3, and so on. So explanation means the how much this particular independent variable contributing to the dependent variable, and this b1, this is the regression coefficient, and we explain this. There are three things we take in. One is magnitude. So what is the magnitude of this regression coefficient? And I earlier told you the standardized regression coefficient value -1 to +1. It means if its b1 value is minus zero point 0.8, it means it is negatively correlated with the outcome variable. It is negatively correlated. Okay. If it's value positive, then it is, we can say, the positive correlation. So first of all, the magnitude. If it is zero point 0.8 means high magnitude, and if b another regression coefficient b2 value 0.123, it is less, it means low correlation. For example, it contributing low to the this outcome variable. So the magnitude, we want to check this magnitude, the strength of the correlation, whether it is highly correlated or medium correlated or small. Okay. Sign tell us whether the correlation between the two variable positive or negative. And third point is statistically significance. So whatever contributing, what means this particular variable x1, if it is contributing to the dependent variable like 5% r square. Okay. So whether it is statistically significant or not. So in our study, like I am taking another example of multiple regression analysis, like b0, b1, x1, b2, b2 x2, b3 x3, b4 x4, b5 x5, b6 x6, and so on. So it is not necessarily that all the independent variables significantly contribute to the dependent or outcome variable. It means if I am taking 6 independent variable, only 3 variables significantly contribute to the dependent variable, and rest of the 3 are not statistically contributing to the outcome variable. So who will tell us whether these variables are significantly contributing or not? This p value. So this p value, the p, if p value less than 0.05, it means these variables are contributing significantly. If p value, if these three variables p value greater than 0.05 means, it means they are not significantly contributing to the dependent variables. So the purpose of the multiple regression analysis, the first is prediction purpose. We can predict ki which particular variable predicting the sales. For example, sales is the dependent variable, and it is depend on the advertising expenses plus price of the commodity plus availability of the product, and many factors influence the sales. So we can predict, then if we spend money on advertising this amount, we can get this sales. If we increase the number of outlet of a particular product, then this may be increased. If we reduce the price of the commodity, sale may be increased. So this is basically prediction purpose we use the multiple regression analysis. Okay. Now second objective, the sample size research design. When we are performing the uh, multiple regression analysis, what should be the sample size? Again, it's a issue when we performing the multiple regression analysis. So in a the sample size, you can see the sample size 5 is to 1. What does it mean 5 is to 1? If we are taking uh, 2 means each variable. So in this bivariate regression analysis, we have two variable, one dependent variable and another independent variable. So what should be the sample size? So 10 should be the sample size for conducting the bivariate regression analysis or simple regression analysis. If my study the six variable like b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus b5 x5 plus b6 b6 x. So how many variable? 1 2 3 4 5 6 and 7. So sample size should be 5 times of the number of variables, it means 35. But preferably sample size should be 15 is to 1. If you are taking 10 variables, then your sample size should be 150. If you are taking 20 variables in a multiple regression analysis, then sample size should be 15 times 300 sample size. Now then second one is sample size and second is variable. What type of variable we should use in multiple regression analysis? So this is my multiple regression analysis equation. And okay, so here y, x1, x2, x3, x4, x5, x6 all are variables. One dv means dependent variable, and all x1, x2, x3 all are independent variables. Now the type of variable, what type of questions we should prepare for applying the multiple regression analysis? So the question should be metric or continuous. It means we should use interval or ratio scale only for performing the multiple regression analysis. Okay, if we, so we cannot take the question means nominal scale question. Okay, so for example this is my equation b1 x1 plus b2 x2. Okay, so here the all the three questions x1 x2 and y, all the three questions in a metric form, metric or continuous data. What does it mean continuous? Means our question should be either interval or ratio scale question. So all the questions including dependent variable, the question should be continuous data should be used. Sometimes categorical data may come in the regression equation like gender or anything. So it is a categorical data, so we convert it into the dummy variables and then we can use the multiple regression analysis. Okay, so the we should keep in mind while performing the multiple regression analysis, all the data should be in the form of continuous data. Now how to prepare our questions for multiple regression analysis? So I will use this case study to perform the multiple regression analysis. So here the this how it's a case study of the company which is engaged in the publishing the paper. Okay, books, they publish the books. So there are they this company wants to know the perception of the buyers, and they prepared perception based questions. So one is national company uses online services. This is simply a statement, and every respondent has to tick between the 0 to 10. If you are ticking 0 1 or 2, it means you are not satisfied, you think the national company online services poor. And if you are taking uh, either 8, 9 or 10, it means you think national company uses online services excellent. This company using excellent online services. So we prepare our question like this, and they say this company provide e-materials to the teachers, paper quality of the book is good, complaint resolved timely by consumer. So these are the questions for preparing the multiple regression analysis. And you can take ratio scale data also, like 0 to 10 के बीच में, it may be between the 0 to 10, or you can take data in the form of rupee, like sales, 30,000, 40,000, 1 lakh. So it is ratio scale data. You can take this data also. Now, then assumptions in multiple regression analysis. So before, we should keep in mind, when we are performing the multiple regression analysis, we should check the assumptions of the multiple regression analysis. First assumption is linearity of the phenomena measured. There should be linear relationship between the dependent and independent variables. Second, constant variance of the error terms. Third, independence of the error term. Error term means, initially I showed you the difference between the observed and estimated, the difference. This is known as error term. And fourth is normality of the error term. Okay, and one is another assumption, multicollinearity issue again. So there should not be multicollinearity among the variables also. Now, what is linearity of the phenomena measured? So how to check whether our data linear or not linear? So this is the example. Through graph, we can check the linearity of the data, whether our data linear or not. Now you can see in this graph there are two variables. One is satisfaction and another is product quality. Okay, so here we can see there is a positively correlated. This is the correlation. This is linear. This is the linear correlation. Okay, so product quality, as product quality increase, the satisfaction increase. Okay, so there is a linear positive linear relationship. So there should be linear relationship between the two variable. It may be negative linear, means the relationship, it may be negative also. So there is no issue, but it should not be like this. It is non-linear. Okay, if the relationship between the two variable like this curve, it is, if it is taking curve, it is not desirable for multiple regression analysis. So the relationship between the two variable, it should be linear like this. It should be linear like this. It should not desirable to like this should not be desirable for our study, and it is also not desirable. So first is, so through graph we can check whether our data linear or not. Now second assumption, constant variance of the error term. Constant variance of the error term, yeah, homoscedasticity. We use the term, there are two terms, homoscedasticity or heteroscedasticity. Homoscedasticity means the constant variance. There should be constant. The error term should be constant. It should not deviate above or below the particular line like this. This is the homoscedasticity means there is no constant error, no constant variance, means constant variance error term. What does it mean? Through graph we can understand it. So in this graph, disperseness of the variables. So this is you can see it is the regression standardized residuals or standardized predicted variables. So you can see here this is 0 value and I am drawing the line parallel to the x axis. This is the line. Okay. And what is here, just it is near to this 2. I am again drawing the line and here I have again this line parallel to the this. Okay. Now it is the disperseness of these residual terms, means the range should be, if range above or below it is same, then there is no problem of the error term. It means it's a constant variance of the error terms. But if it takes the shape of the funnel shape like this, if variation or disperseness of the data like this, so it is not desirable. Okay, then we will say it is heterogeneous data. Now it is homogeneous. Okay, so through this graph we can find whether our data homogeneous or not. And third is independence of the error term. So through Durbin-Watson test we can check. Through Durbin-Watson check we check the of independence of the error term. So generally its value should be perfectly Durbin-Watson test value should be 2. But if it is between the 1.5 to 2.5, it is good. There is no problem of independence of the error term. So its value may between the 1.5 to 2.5. If our value uh, come between the 1.5 to 2.5, it means there is no issue of the independence of the error term. So through this value we will find the independence of the error term, whether independence of the error term yes or no. Okay, now normality of the error terms. Normality, so here we are not checking the normality of the individual variable, but normality of the error term. And what is error term? Error term means estimated observed minus estimated, means difference between the observed and estimated value. So the normality through histogram we can check. So here it is normally distributed, means more or less it is bell shape. Okay, independence, what does independence, okay, independence of the error term, independence of the error terms. So independence of the error term, basically we use this term in a when our data is time series data. Independence of the error term means ki, for example, in a cross sectional study, if in a cross sectional study there are 100 participants, if you are giving uh, opinion to a particular question, your data should not be copied by anyone, means your data should be independent to another participant's data, means you will not copy with other. So it is independent of error terms. Or in the error term, I told you it is the difference between the observed and estimated. So in a uh, the time series data, the observation of day 1, day 2, day 3, day 4. I have 365 data, and each day data, that is the error term, means observed minus estimated. This is error term, observed minus estimated. It means this is multiple regression analysis. Basically, it's a model, and no model perfectly predict the phenomena. So there may be error. Always you will find the error. So the error of day 1 should be independent of day 2, independent of day 3, day 4, day 5 days. So it is basically error term should be independent. There should not be correlation between the two error term. If it is correlated, then we will say assumptions of a multiple regression analysis, this assumptions does not fulfill. So the independence of the error term in a cross-sectional data, your observations, your opinion may be complete unrelated to the other participants observations. Normality. Okay, now the next is normality of the data, the through histogram, the bell shape, the distribution of the error term should be in a bell shape. And then next we can find through the this pp, normal pp plot, means probability plot. All the observations should lie on this diagonal. If it is deviate from this, if it is deviate from the diagonal, then we say it is not normal. So here we can say more or less maximum observation are lying in this particular diagonal. If it takes the curve or shape like this and like this, so it is not normal, because it is taking shape, curve shape. Okay, but theoretically all the observations should be lie on this diagonal. If all the observation lie on the diagonal, then we can say this is the normal data. Okay, then regression model fit. I will explain these terms with the example like multiple correlation, r square. These we use as stepwise estimation to perform the multiple regression analysis. And then r, it is a r basically it's a correlation. In case of the in case of the simple bivariate correlation, like y equal to b0 plus b1 x1. So this is known as the multiple r means it is the correlation coefficient for bivariate correlation. And its value uh, positive, we take always positive value, because in a multiple regression analysis many independent variables may be negatively or positively correlated with the dependent variable. So here we take multiple this value positive, and when we square of this value, square of this, it is r square. It means coefficient of determination. So I will explain all these terms in a practical when I explain the practical. So the standard error of the error terms, it means the prediction error, it should be near to the regression line. If it is, so it is desirable, it is not desirable, because these observations are much dispersed in comparison to a graph. And the ANOVA table, through ANOVA table we find the F ratio and regression coefficient value, standardized regression coefficient value between -1 to +1. and standard error of the coefficient means how precisely the model estimate the coefficient unknown value. Okay, and its value always positive. Then t value, we find the t value in a regression model. It is divided by the standard coefficient divided by standard error. Then zero order part and partial correlation, zero order. So we will explain in a example. Through I am taking the case study of I will use two case study to perform the multiple regression analysis, and then I will explain the output. Now the issue of multi collinearity. So the how to find the multi-collinearity among the so the multi-collinearity means there are two methods to find. One is variance inflation factor and another is tolerance. The value of the inflation factor, so if it is higher than the 10, then it create the multi-collinearity problem. And the minimum cutoff value of the tolerance is 0.10. That is, the tolerance value must be smaller than 0.10 to indicate a problem of multi-collinearity. So through practical, we can check whether our data or observations have multi-collinearity problem or not. So this is the result interpreting the regression variate. And the this equation came from the previous example. So here there are, I have taken 14 independent variable. Out of the 14 independent variable, only the 4 or 5 variables are only 5 variables statistically significantly contributing to the dependent variable. So, and validation of the result, we can split our sample into two, and then we can check whether cross validity exists or not. Okay, so mm, so to hello.
Sir, you are audible, sir. You are
Okay,
audible.
okay, okay. सर ब्रेक था 11:30 हो गया, उसके ब्रेक के बाद हम प्रैक्टिकल ले लेंगे.
जी सर, जी सर.
जी जी, है ना, 12 बजे से फिर हम उसको प्रैक्टिकल ले लेंगे.
ओके सर. Now you have to break off half an hour. Again, our session will resume at 12. But everybody be online. Sir, can we back again, sir?
Yes, 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 yes. Thank you, thank you, thank you.
Okay.
Okay, sir. Thank you very much, sir.
So you have to continue, sir.
Yeah, yeah, yeah. Sure, sir. Sure. Thank you. Welcome back, dear participants. So now I am taking the simple bivariate regression, simple regression analysis by or bivariate regression analysis. So,
Sir, screen is not visible, sir.
yes, yes, yes.
Now visible, sir.
Okay, okay. Thank you, sir. So, dear participants, in this case study, it's a case study of bivariate regression analysis, and you can see the data set of this. Now, in this case study, 50 observations here you can see, and there are two variable years and salary. Now, how to enter data for multiple regression analysis? So here, sorry, bivariate regression analysis, I am taking two variable. One is years, number of years. Okay, so here I have written in a short form years, or you can simply write the question number one. So because here we do not have enough space to write the full question, so here I write the small word. Okay, now the full question we will write in a label section here. So here number of years in employment. The short form of this question is years. I have written here in name. And then second question is salary. So salary, the my full question in a label, you can see salary in rupees. So we write full question in label, and in a name column, we do not have enough space to write the full question. That is why we have taken the short form of this question. Now, the both the questions should be scaled because data is our data for bivariate regression analysis either continuous means interval or ratio scale. Scale means it has the property of interval and ratio scale. So both the questions in a ratio scale. So this is the case study. So in this case study, 50 observations, we have 50 observations. The person who has 1 year experience, his or her salary 35,000, 15,000, 26. It's a hypothetical data, 37,000, 38,000, and the experience of 2 years salary, you can see here 27 to 40,000. Experience of 3 years, the salary is this. Experience of 4 years, the salary is this. So we want to check whether number of years means experience influence the salary or not. Is it related or not? So through graph, we can see what type of relationship we have in this data. So chart builder, and then first of all, I want to check what type of relationship between the two variables, and then here, so this is I'm preparing the correlation graph scatter diagram. Through scatter diagram, we can understand the nature of the two variables: salary dependent variable and number of years. It is independent variable. I am taking here in a x-axis, and both the variables categorical, and then clause and okay. So I am stop sharing and showing you the graph. This is my graph. You can see here. This is the graph. So in this graph, we can see there is a positive correlation between the number of years in employment and salary in rupees. As your experience increases, your salary may increase. So there is a positive correlation. Now, I perform the bivariate regression analysis. Now, this is how to perform. So first of all, analyze, then regression and linear. Analyze, regression and linear. And then now you can see here two variables. So salary, it is dependent variable. So I am putting here in a dependent box. And number of years, it is independent. So here I am transferring in independent. Okay. Then statistics. So I need only descriptive. There is no role of part and partial correlation, single variable. And then continue. And then plots, we can see the Z predicted X and Z residual Y. Okay. Standardized residual or standardized predictor variable. And then we can create histogram, normal probability plot, produce all partial correlation, because it will not give the partial correlation because it has only the one independent variable. And then continue, and after continue, options, and then okay. This is output of bivariate regression analysis. So then descriptive statistics, we can see here mean value 49,360 and standard deviation, that is 20,003.23836. Okay. Same as it's a mean value of the number of years in employment and it's a standard deviation. And then it is a correlation between the two variable. It is positive correlated. We have seen through the graph also. There is a positive correlation. As number of years increase, the salary increases. Okay. And then it is significant p value.
Excuse me, sir.
Yes, sir.
Sir, your graph is not visible.
अच्छा, graph मैंने भी okay. Graph I have shown earlier. This is now I am not showing the graph. Earlier I show the graph. You can see now graph. I'm just.
Since you are explaining on the graph.
Okay. Yes, these are the graph. So I will. Actually, this is the graph. Okay. So in this graph, we can see now. Can you see, sir, graph?
Yes, sir. Now it's visible, sir.
Okay. Thank you. Now in this graph, we can see the positive correlation between the number of years in employment and salary in rupees. Okay. So as number of years increases here 0, 5, 10, 15 in x-axis. So as number of years in employment increases, the salary increases. You can see in a vertical axis 20,000, 40,000, 60,000, 80,000 and 1 lakh rupees. So there is a positive correlation between the two variables. So through graph we can understand. Now I was talking about the descriptive statistics. The mean value of the salary, that is 49,360. It means when we combine all the observations of the salary and divide it by the 50, sample size was 50, then salary mean 49,360 and standard deviation, that is 20,003.836. Standard deviation basically tell us about the dispersiveness of the observations. So for example, this is my graph. So we can understand this is the x-axis and this is y-axis, And here the mean, this is my mean value y bar, that is 49,360 and something. So standard deviation means individual observations disperse the above and below the 20,000, means it may be the highest value, not highest, the disperseness of the individual observation, means someone value of individual observation value like 60,000, okay, someone value uh, 40,000. So it's a basically a standard deviation. It's a it's a deviation from the individual observation, how individual observation deviate from the mean value. This is less less standard deviation means it tell us about the consistency of the data. If maximum observation near the mean value, it means it's less standard deviation. And if it's the deviation is more like this, so it is uh, telling the disperseness about the data, how this it means it is not consistent data, it is heterogeneous type of data. So and then we can see here the positive correlation between the two variables. This is the r equal to 0.780. And through graph we have seen as the value of years, okay, this is the x-axis and this is y, salary and years. As the uh, number of year experiences increases, the salary also increases. So it is a positively correlated, this graph it is showing the positively correlated. Now the next the entered the variables, the only one independent variable we are taking, so it is showing only the model one. Okay, now model summary, what does it mean, the model summary? So model summary tell us about the R, it is multiple uh, R, and it is R square, it is coefficient of determination, and this is adjusted R, and it is standard error of the estimate. Okay, so what does it mean? Standard yeah, this R basically it is multiple R. It is the correlation between the it is a simple correlation between the dependent and independent variable, like b0 plus b1 x. And what is x? X that is number of years, number of years in employment, and y means salary. Okay, so this is simply the regression coefficient. This regression coefficient simply the correlation between the dependent and independent variable, and its value, this is 0.780. And through the correlation matrix, earlier we have seen the correlation between the number of years in employment and salary is 0.780. Now the square r square means coefficient, r square means coefficient coefficient of determination. Okay, so its purpose, we use r square for interpretation purpose means, so in this example we can see the 0.78. If we square the value of the 0.78, okay, 0.78, then what would be the value will be here. You can see the point. This is r square है ना. So r square value 0.608, or in a percentage term, if we convert it into percentage, then we can say this particular variable, independent variable, number of years, is explaining 60.8% of the dependent variable, that is salary. Okay, so it means ki how much of the variability. So this r square tell us how much of the variability in outcome variable is accounted by the number of years or predictor, this particular predictor. So it means 60.8% vary this particular independent variable, vary the outcome variable 60.8%, and rest of the unexplained part by the other predictors. Now the standard, uh, the the another is adjusted r square. Adjusted r square, basically this adjusted r square value and r square value should be more or less same or near to r square value. If adjusted r square value away from the r square value, we will say our model is not fit. So it is more or less same. So for cross validation purpose, we use the value of adjusted r square, whether it is near to the r square or not. So basically r square, adjusted r square gives us some idea of how well our model generalize, and ideally we would like its value to the same or close to the r square. So basically we use for generalizing our model, if it's adjusted r square value near to the r square, it means our model is good. Now then standard error of the estimates. Standard error of the estimate is another measure of accuracy of our prediction के लिए we use this term. And the estimate, the and standard error of the estimate, basically it's a standard deviation of the actual independent value around the regression line. This is our regression line. So we use standard error of the estimate for prediction purpose, and the value, these are the value of the standard error of the estimates. If the value near to the regression line, then we can say it is good. If it is deviate much about the regression line, means like this it is okay, so it is not good or desirable for our study. Then how to find this, I will explain in a next lecture, oh sorry, next case study for multiple regression analysis, because here we do not have many terms output like multicollinearity and the partial correlation we cannot do in a bivariate regression, because it has only one independent variable. Then ANOVA table. Now the ANOVA table basically tell us about the whether our model is significant or not. So here this is the f value, and this one is p value. P value means probability value, and it should be less than 0.05 for checking whether independent variable significantly contributing to the dependent variable or not. So here there are two terms, regression and residuals. Okay, so total sum of square equal to the sum of square regression, or we can say model, plus sum of square residual means error term. Okay, so this, so here regression, so this value, it is you can see this is the explained part value, and this is unexplained part value. So always this value should be greater than to the sum of square residual. We need the this explained part should be high, this is explained, and unexplained part value should be less. And then when we divide it by degree of freedom, then we obtain the value of mean square and mean square residual and mean square regression. And when we divide it this mean square this, then we obtain the f value, and f value, it should be greater than 1.96. Okay, so here it is very high value 74.335, and p value again significant. It means this independent variable is contributing significantly to the dependent variable. Now the next here we can see the term, the coefficient. Okay, in a coefficient, what is the coefficient? This is our intercept, and this is the value of regression coefficient, and this one is standardized regression coefficient. But for interpretation purpose, we use unstandardized regression coefficient. This one we use uh, for interpretation purpose, we use this term. Okay, now what would be our equation? So our equation would be y equal to, how to write it? So y equal to this is b0 plus b1 x1. Okay, only one. So y means salary equal to b0 to 9067.173 plus 2882.5 into what is the independent variable? Number of years in employment. So this is my model. It is known as model. This is model. This is my model for bivariate regression analysis. So we should write this model in our research paper or thesis. Okay, now this is intercept, this b0, it is intercept value, and regression coefficient or multiple r value is 2.288.5, and number of years, that is independent variable. What does it mean? So here we can see the 2.882.5. This is regression coefficient. What does it mean? This value indicates that the number of years, as number of years increase 1 unit. Okay, for 1 year, if you have 1 year experience more, then your salary will be like this. This means 29067.173 plus 2882.5. So we will add this, This is after, means 1 year experience. If someone has 1 year experience, his or her salary will be this. If someone has experience of 7 years, okay, then we will put the value here, and this into 7, and then we will add this value. So we can predict through this model, if someone has 8 year experience, what would be the salary. If someone has 10 year experience, what would be the salary. So through this model we can predict the salary of employee. And here now, standardized beta coefficient. For this, we use standardized beta coefficient only for interpretation purpose. But when we write the model, we use unstandardized. This is the unstandardized coefficient. So it is telling the correlation between the dependent and independent variables in a simple regression analysis. It is, we have seen through graph also, it is a positive correlation. And next is t. T means t value. T value. So whether this t value is significant or not, so we check through this formula, b upon standard error. B means regression coefficient. This is regression coefficient, and it is SE means standard error. When we put here b, what is the value of b? This is the value of 28 8 2.50, and divided by 334.329. So this we will obtain the value 8.622. Okay, and it should be greater than 1.96. Then we can say it is significant. And here p value, it is less than 0.05. Okay, so here the p value should be less than 0.05. Okay, so this is about the bivariate regression analysis. So I will cover assumptions of the multiple regression analysis in a multiple regression analysis case study. So it is bivariate. So I'm taking the another case study. I'm stop sharing this and taking another case study of multiple regression analysis. Now you can see. Okay, this is my this is case study. Okay. No, your question is which value should be reported in research, R square or adjusted R square. We should report both the value, but for interpretation purpose we use only R square value. Okay. How to plot linear regression line graphically for bivariate. Okay, so how to draw the linear regression line in a graph. So I just I am taking the, I am stopping this slide, and I am drawing the regression line. Okay. Okay, this is the case study. Now I am preparing the graph, graph chart builder, and then the I'm taking the scatter diagram. So here number of experience, I think you can see in, I'm putting x-axis and salary in y-axis. Okay,
Excuse me,
now
sir.
yes, yes.
Sir, your output screen is not visible to the participants.
Okay. So okay. Mhm. this is not visible and stop sharing. Okay, this so this output stop sharing. And okay, now can you see this graph now? Okay, this is the graph, the bivariate regression analysis. Okay, now your question, the
Yes, sir.
participant's question was how to draw the regression line. Okay, we just double click this graph. Okay, after double clicking, you go to elements and then fit line at total. Okay, this is the fit line at total. This is the, now you will tick it, and after tick you can see the regression line on this particular graph. Okay, now I am taking the case study of multiple regression analysis. So I am sharing the slide, uh, the multiple regression. Yes. So again, your question, if a regression model has highest R square but lower adjusted R square than the other, which model we should be preferred? So basically R square value always greater than the adjusted R square. Okay. Now, the this is the case study of multiple regression analysis. So there are four variables: sales, advertising, discount, and shops. Okay, now in this case study, the sales of a particular product may be anything. So here the sales sales, advertising, discount, and shop. So sales here dependent variable. Sales depend on advertising, discount, shops. Okay. Okay. How to interpret F value? So I will explain in this multiple regression analysis, because I did not explain every term in bivariate regression analysis, but in a multiple regression analysis we will get all output. So we will check the assumptions of the multiple regression analysis, how to interpret the F value, ANOVA table, so part and partial correlation. So I will explain in this output of this multiple regression analysis. Okay. Now, in this, the units in 1,000. So it's a hypothetical study. So we here we can see the sales as a dependent variable, and sales depend on advertising expenses. Now you can see here the this is my equation: y equal to b0 plus b1 x1 plus b2 x3 plus b3 x3. Okay, b2 x2. Okay, this is my equation. Now here x1, what is y? Y means sales. This is dependent variable, and condition of this dependent variable, it should be continuous. Data should be continuous. So continuous, it is ratio scale data. Okay, there are four types of scale: nominal, ordinal, interval, and ratio. It is ratio. It is desirable for our study. And x1, what is x1? It is advertising expenses. Okay, and what is x2? X2 is discount, and x3, this is number of shops. Okay, number of shop, availability of the product. If the availability of the product in a 2 shops, and if availability of the product 50 shop, naturally availability of the shop also influence the sales. So this is my model. Here y equal to b0 plus b1, x1 means advertising expenses, plus b2, x2 means discount. If we give discount, naturally sales will increase, and number of shops. Here this is third variable. Okay. This is the case study, and we have observed how many observations. We can see the observation 100 observations. And how to enter data in SPSS. So this, I told you, the full, we will write the full question in labels. Okay, there are 4 questions, and short form of this question we will write in name column, because here we do not have enough space to write full question. So in a short form of this question, we have written here sales, advertising, discount, and shop. When we see the data view and put the cursor over here, cursor on sales, then we can see the full question. What is written here? Sales in advertising budget in 1000 in a yellow rectangle, and you can see discount on product and number of shops. Okay. B1, B2, B3, these are the regression coefficients. B1, B2, B3 called the regression coefficient. Okay. Now, so this is my this is the case study. Now I am performing the multiple regression analysis. So first of all, we check the correlation, whether correlation is statistically significant or not. Although we can do it in multiple regression analysis also, but here we want to check the correlation, bivariate correlation. Analyze correlation bivariate. Okay. Now we can see we select all the 4 variables and transfer in this box variables, and then Pearson correlation, and okay. After okay, I am showing you the output. This is output. So through this data, we can see the sales related positively with advertising expenses, with discount, again positive related, and number of shops also positively related. What does it mean? It means we can see the, so explaining this. Okay, so in this diagram, this correlation, it is correlation matrix. So here the dependent variable, what is the dependent variable here? The advertising expenses, y. Now the advertising expenses, sales is dependent variable, and this you can see the value r, that is 0.606. okay, with advertising expenses r1, and r2 means discount. What is the relationship? Positive related with salary, sales, and 0.565, and r3, it is number of shops, 0.290. So we can see the advertising expenses highly related with the sales. So first of all, our model should take this advertising budget first. Okay. No, this is, or we can see through graph also the relationship between the variables. I'm stop sharing and I'm preparing the graph of three graphs chart builder. So I think it will not show. I'm just scatter diagram. I am preparing the graphs. So I will show you all the three output. Okay. So I'm preparing the graph. This one, and then I'm just this after advertising budget I'm taking, because you cannot see. I will show you the output directly. So the third graph, number of shops. Yes. So now I am showing you the output. So output, this is output. Okay. Now I prepared the three graphs. Now the first is advertising and sales in thousand. So it is positively related. So here we can see there is a positive correlation through this graph. So I am drawing the regression line. This uh, so double click and then elements. This is second graph, and then you can see the positive correlation. This is third graph, element fit line net total. Again it is positively related. So the another graph was, yes, this is this graph, advertising budget and sales. Again it is positively related. Double click and then you can draw the line, elements fit line at total. This is okay. So through graph we can see there is a positive relationship between the all the three variables. Now I am performing the multiple regression analysis. Okay. So analyze and then regression and linear. Okay. So analyze, regression and linear. Then what should we do? uh, After clicking sales, it is dependent variable. We will drag and drop here, dependent. Okay. And then advertising, all the three variables simultaneously we can select and transfer independent here. Okay. Now click statistics. This is the statistics. Now you can tick R square change, descriptives, part and partial correlations, collinearity diagnosis, confidence interval, Durbin Watson test. Okay. So estimates, confidence interval, model fit, R square change, descriptives, part and partial correlation, and collinearity diagnosis. Why are we using collinearity diagnosis? For checking the multi-collinearity among the independent variables. And then Durbin Watson test, another assumption of multiple regression analysis, and then continue. Okay, after continue plots, then Z predicted. Okay, I am selecting Z predicted and transfer x-axis. So Z predict x-axis and Z residual above here in a y-axis. Okay, Z predict in x-axis, Z residual in this y dependent variable. Now standardized residual plots. One histogram, it tell us about the normality. Normal probability plot produce all partial plot. Why are we taking this? For getting the linearity of the three independent variables with dependent variables. Okay, and then continue. Options, nothing to do, and enter. Here I am taking stepwise. Okay, this is the way to perform the multiple regression analysis. I am again entering the data. So first of all, analyze regression linear. Okay, then sales in dependent box. All the three variables simultaneously select and transfer into this box, and then statistics, R square, descriptive, part and partial, collinearity, confidence interval, Durbin-Watson, and continue. Plots. So Z predict in x-axis, Z residual, standardized residual, y-axis, histogram, normal probability plot, produce all partial plots, and continue. Options, nothing to do, and then select stepwise method, and then OK. Now I am showing you the output. This is the output. I think you can see the output. So I'm explaining one by one. So first table, descriptive statistics. There are two things. One is mean and another is standard deviation. So mean value of sales, that is 19,246, and the standard deviation 8,841, and then advertising mean of this 1,179, and standard deviation this, and the discount on products, the third variable 28.39 mean value, and number of shops is this. This is the mean value of all the four variables, one dependent and three independent variables. In a second column, the standard deviation, and the third column you can see the number of cases. We have 100 observations. Now correlation matrix. Through correlation, we have seen that the advertising expenses more positively correlated with the sales. Okay, and rest of the correlation, discount on products and number of shops less in comparison to advertising budget. Now this is the model summary. Okay, now we should understand the meaning of model summary. The model summary, the first, there are three models. Now in the first column we can see model 1, model 2, model 3. What does it mean? First of all, we understand it. Model 1 means when we take only one independent variable with dependent variable. This is the model 1. So model 1, in a model 1, so model 1, the sales, this is dependent variable, and the advertising budget, advertising budget, another model, or we can simply write v0 equal to b0 plus b1, or multiply advertising budget, or simply x1. When we take one independent variable with dependent variable, it is known as model 1. In a model 2, we take two independent variables, b1 x1 plus b2 x2. What is y? Sales. So here you can see this is the dependent variable, sales. And in model 2, what are the predictors? Two predictors, one is advertising and second is uh, discount. In model 1, only one predictor, advertising, but in model 2, advertising and discount. So here x1 means advertising expenses and x2 means discount. Okay. Now model 3, model 3, here we are taking three independent variable, b0 plus b1 x1 plus b2 x2 plus b3 x3. Okay, so here what is x1 in the third model? C, the x1 is advertising budget, x2 means discount on product, x3 means number of shops. Okay, so this is about the model 1 2 3. If I say a model 2, it means I have one dependent variable and two independent variables. Second is the r square. Second term is r square, sorry, r. So r value, r, it is multiple r, it is known as multiple r. Multiple r basically is the correlation coefficient. ठीक है ना, जैसे बाइवेरिएट रिग्रेशन एनालिसिस में हम लेते हैं, इट्स सिंपली ए कोरिलेशन बिटवीन द डिपेंडेंट एंड independent variable for only simple regression analysis. It is same as the correlation between the dependent and independent variable. Okay. Now the r square, what does it mean? So I earlier told you r square, basically it is the coefficient of determination. Then how to find the value of r square? So r square, we can see here the formula of r square, sum of square, sum of square regression, and total sum of square, total sum of square, sum of square residual. Okay, although we can square it. Okay, so if we square of this, we will get the value of r square. So what would be the value of r square if we square this? R square equal to 0.367. Another formula to find the r square value, sum of square regression. So what is the sum of square regression? Sum of square regression value is this. Okay, so I am writing here 28410776600 and divided by the residual. This is the, sorry, total total sum of square residual. And So total is so it's a value of not residual. Sorry, I, it is total sum of square. Okay, so what would be the value? This value 7738 uh, 569645. When you will get the 0.367. Okay, although we do not need to find through this, so we just square of this value, square of r, so we will get the r square. So r square basically the value of r square, that is 36.7% in the first model. It means when we take only the one independent variable, then this independent variable y equal to b0 plus b1x, this advertising this particular, the first model, the advertising expenses or budget contribute 36.7 to the sales. Okay, so here we can say the advertising budget accounts for 36.7 of the variation in sales in the first model. Now model 2, model 2, what is the value? Model 2 r value, so r value is 0.772, and when we square it, what is the value after r square value? 0.597 point, or we can write in percentage 59.7%. Okay, so it tell about the 59.7%, uh, 59.7%, it increases. Earlier it was when we are taking the single variable r square value 36.7, when we taking the two variables 59, then its value increases, and it shows the 59 point, sorry 59.7% variance in sales uh, of two variables. Two variables means advertising expense budget, and another the second discount. Okay, means these two variables vary the dependent variable 59.7%. Now in the third model, what is the r square value? In the third model, r square value, we can see here the r equal to 0.788 and r square value uh, 0.621, or we can write it 62.1%. So 62.1%, this is the value of r square. So this is the value of third model. Okay, third model value. It means all the three variables: advertising, budget, discount, and number of shops. All the three variables, the 62.1 of the variance in sales because of three uh, independent variables. And if we subtract 62.1 from the 100, it means the rest of the variance can be explained by other predictors. Okay, so in this model, our model is 62.1, very correct, very for the dependent variable. Now the x adjusted r square. Now we should keep in mind always adjusted r square value always less than the r square. Okay, because its formula you can check the adjusted, or you can calculate the adjusted r square, because you can see the formula. This 1 minus r square and n minus 1 and n minus k minus 1. This is the formula of adjusted r square. So here n means number of observations. We have 100 observations. K means number of predictor variables. So we are using three independent variables: advertising, discount, and shops. Okay. When we put all the value here, 1 minus r square. So mm, I'm taking this value. Yeah, I'm finding the adjusted r square value of third model. Okay, so 1 minus, what is the r square value? So here 0.621. Okay, and n 100 minus 1 upon 100 100 minus 3 independent variable and 1 this. Okay, so we will find the value of adjusted r square. This is 0.379 and 99, and so it is 96. So our value will be point, after calculating it, 390 equal to 0.609. This is the adjusted r square value. We can calculate through the formula. Now you can see 0.609. Okay, so this value always less the r square value, and it basically, this adjusted r value give us idea about how well our model generalize. Okay, and ideally its value, adjusted r square value, near to the r square value. If we subtract this value, the 0.621 minus 0.609, this is the difference. And what is the difference? 0.012. It is less. Okay, so it is almost 1.2%. 1.2% less. So this 1.2%, or difference between the r square and adjusted r square, it is known as shrinkage. 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 This term known as shrinkage. It means if the model were derived from the population, if we are taking driving our model from the population rather than a sample, it means it would account 1.5% less variance in outcome variable. So its value always, adjusted r square value always less than the r square. And so basically we use this value for cross validation purpose also. Its value near to r square. If its value near to r square, it means our model is fit. Now the next is standard error of estimate. So what does it mean, standard error of estimate? Basically, standard error of the estimate is another measure of accuracy of our predictions. Whatever predictions we are doing, so through standard error of estimation we can know. And then what does it, how this value come? How will we find standard error of the estimate equal to, this is the formula to find the value, sum of square residual means error term, residuals, and divided by degree of freedom. So what is the value of sum of square residual? Here this is the value of 489. So we will put here 4897 4949 2044 divided by degree of freedom, and degree of freedom is 98, and then, or you simply we can divide it 98, and then we take the square root, so its value will come about 7069. Okay, so we can check this value also. It represents an estimation of the standard deviation of the actual dependent value around the regression line. This is our regression line. So these are the basically observations. Okay. Next is R square change. Here we can see the R square. So what is the R square change means? In the first model, the R square would be same. There will be no change in R square. So in the first model, our R square value 0.367. So it is same. Okay. And next, the F change. This is the F value. So this F value, this is the F value 56.851. We should keep in mind F value should be high for significant model. Its value not should be less than 1.96. Its value should be always high value. It is acceptable. So F value tell us whether our model is significant or not. Now, okay, then degree of freedom, then F change, and this is the Durbin-Watson test. So it's a assumption of, so I will discuss it later on when I take the assumptions of the multiple regression analysis. Okay, now this is the about the first model. Now for second model, this is R square change. What is the R square change? 0.230. How did it come? So from this, so we subtract 0.597 minus 0.367, and the difference is 0.230. So this is the R square change. Earlier R square was 36.7, and another R square 59.7%, and the difference is 23. When we add another independent variable, the R square increases 23%. So whether this R square change is significant or not. So here we can see it is significantly contributing. This R square significantly contributing to the second model. Same as R square change in third model. So we we subtract the value 0.597 from the 0.621. This is okay. This value, we take the difference 0.621 and 0.597. So what is the difference? This is the 0.024. This is okay. Now difference is very less. Now when we check whether this less difference is significant or not, so this p value tell us again it is less than 0.05. It means This small r square change means 2.5%. It is also significantly contributing to the third model. Now the f value, so how will we calculate this value 55, because here there is no value of f change. So we uh, know how to calculate the f change value. Basically f ratio, what is f ratio? F ratio, it is the sum of a square regression model and divide by mean, the sum of a square residual. देखिए this f ratio, this is our f ratio. So f ratio means sum of a square regression, square regression divided by degree of freedom, means we will get the mean square regression and mean square residuals. When we divide the f ratio equal to f ratio, this equal to 2841077600 and divided by 49974408. So we will get 0.56 or 0.5685, or in a percentage we can convert it 56.85 percentage. Okay, now question is how to find this value f uh, change, because this value can be taken from this table and our table, but how do we find the value of f change? This value 55.190. So there is a for the first model f value, the for first model 1. Okay, for model 1 f ratio equal to n minus k minus 1 square upon k 1 minus r square. Okay, I'm talking about model 1. So sample size 100. I'm taking only in model 1 one independent variable and one. Okay, and then sorry, r square. This is r square and r square in the first model, this 0.367. So I am writing 0.367 and 1 minus r square 0.367. So we will get the 56.81. This is this value. Okay, now for model 2 f change, model 2, for model 2, so what would be the value? f change equal to n minus k2 minus 1 upon k change 1 minus r2 square, r2 matlab model 2, and then r change. This is the formula for finding this value 51.9. When we put all the value here 100, and in the second model 2 independent variables and r square change 0.23, 0.23, and then 2 minus 1, because 2 variable and previous variable, previous model 1 variable. So 2 minus 1 and 1 minus 0.597. So we will get 55.190. Same as we can find the value of this f square change. So this is about the model summary. Now the second is ANOVA table. ANOVA table tell us about whether our independent variables are significantly contributing to the dependent variable or not. So here, this is my model, b2x2 plus b3x3. Okay, so this is the first model. In first model, when we are taking only this one independent variable, it means this value, this p value, it is less than 0.05. It means this independent variable x1 means advertising. Here you can see the advertising significantly contributing to the sales, because p value less than this. Now the case of model 2. Model 2 means we are taking two independent variables simultaneously, x1 and x2. So here again the p value, it is less than 0.05. It means the two very independent variable advertising expenses and the discount significantly contributing to the dependent variable y. Now the third model. So here we are taking all the three variables simultaneously. So it means the all the when we take all the three variables simultaneously, x1, x2 and x3, means these all three independent variables significantly contributing to the dependent variable. All the models are fit. Okay, so this is about the the, the ANOVA table. So here you can see the total sum of square equal to total sum of square regression, and sometimes we can write model plus total sum of square residual or error, we can write it. So here the total value of this 77 3856 9645, it is decomposed into two parts, total sum of square and total sum of square residual. So these are these value. When we divide this degree of freedom, we will get the mean square regression, mean square residual, and when we divide the regression by residual, we will get the value of f. Okay. No. Constant, you are saying constant is not significant. Yeah. There are two questions. So R is high. What does it signify? Okay. R high means, now another question. So I am taking your queries. So first is what should be the ratio of mean and standard deviation in any statistical tool? So the ratio, basically there is no ratio here. Standard deviation, basically it is the standard deviation basically tell us about the distribution of individual observation about the mean. If its value near to the mean value, then we can say less standard deviation, and the data is consistent, and it is uh, deviate from the mean value means higher, it means data is heterogeneous. Second, a regression model has R square adjusted this. The other regression model adjusted R square this. Which model should be preferred? Okay. So basically, the regression model has R square is zero point 0.6, and the adjusted R square you retain here 0.5556, and the other regression model R square is this point R square, adjusted R square. Which model? Actually, this the model, it if our model, okay, you can see there are three model 1, model 2, model 3. So whether the R square it is significant or not, so we can check through this ANOVA table also. In the first model, we can check whether this R square is significant or not. So through this table, ANOVA table, we can check whether R square significant or not. Here p value is less than 0.05, it is significant. When we take R square 0.597, is it significant or not? So we can check through this ANOVA table. Yes, in the second model, again it is significant. For when our R square value 0.621, is it significant or not? Yes, it's significant because its p value 0.05 less than 0.05, and we can check through this table also. Here it is significant, it is significant, it is significant. Okay, so another question, your, so model contrast constant is, no, we should so Mr. Atul Kumar question, you're in a model 2, if it is not significant, because we do not take constant, it's a constant value. So here our purpose to describe the regression coefficient b1, b2, b3, these should be statistically significant. These all the three coefficients value b1, b2, b3 should be less than 0.05. Is it it is necessary to f value will be higher always even model is yes, this way its value should be higher. Okay, now I am explaining the next table. So next table, this is the coefficient, this is my main table. So here in this coefficient, we can see here the coefficient, the first model. Okay, in the first model, so this is the model 1, model 2, model 3. Okay, now I'm explaining one by one. So model 1, model 2, and model 3. I'm just coming, 1 minute. You just please wait 1 minute. I'm just coming. Okay. So I was explaining the three model. So in the coefficient, so first of all, the how to write our model. So my final model is this model 3. So we should write in our research paper or this model. So y0 equal to minus 7306.42 plus, and regression coefficient of first independent variable 0.917 into x1. Okay, x1 means advertising budget, and second is the 326.932 into x2, and plus the third independent variable regression coefficient 1003.005 x3. So we should report this model in our study. So for reporting purpose, we take unstandardized coefficients. Okay, unstandardized coefficient. We take all the, this is our intercept, and these are the regression coefficient of three independent variables. Now, what does it mean? So this is my main model, and so B value tell us about the relationship between the sale and each predictor. So here you can see the B value. These are the B means coefficient. This is the B1, B2, B3. These are the regression coefficient. These are the B value, unstandardized. Here you can see this one, and this one. These are the three values. So these values tell us the relationship between this variable with this. It is positively related. Okay. And a positive B value indicates positive correlation between the dependent and independent variable. So here we can see all the three independent variables positively correlated with the dependent variables. Now, what does it mean? The first term. So I am explaining the first term. First means one by one. I am taking three independent variable one by one. I am explaining. Okay. So this is minus 7306 plus 8.917, and x1 means advertising expenses. What does it mean? What is this 8.917 is telling to us? This value indicates yes, मेरे ख्याल में आ गया. Hello, can you hear me? Some electricity problem.
Yes,
Okay.
sir. Now
Sir,
it's
we can
okay.
hear.
Thank
Yes,
you,
sir.
thank you. Actually, some internet interruption due to. Okay, thank you. So I'm sharing again my output. Okay. Can you see this output, sir? Please inform me.
Yes, sir. Yes, sir. We can
Okay.
see.
Thank you. Thank you. Thank you. So I was explaining the model first. So means y equal to minus 7306 point 423 plus 8.917 and x1. Okay, I am explaining the model 3 and only one independent variable I am taking. So my question is, what is the meaning of 8.97? So meaning of this value indicates this value indicate that advertising budget increases by 1 unit. This advertising budget increases by 1 unit. Sale will increase this time. Means if I am uh, if my budget, if I increase 1 unit in budget, okay, so my sale, if I'm not using any money on advertising expenses, means zero value, so my sale may be uh, negative. Okay, but this if I am using 100 units, so minus 7306.423 plus 8.917 and this unit in 1000, if I am using 100, so this this is okay. So we multiply it and we will get the sales. So here it simply means the advertising budget, this X1 budget increases by 1 unit, sale increase by 8.97 units. Okay. Now another when I take the another variables, so the my second variable was minus 7306.423 and this is 326.932 x2. X2 means uh, discount. It means this value indicate that as the discount increases by 1 unit, for increasing the 1 unit, then sales may increase 326.9 units. Okay, same as for third variable, that is third independent variable, y equal to minus 7306 for 2 plus 1003, sorry, 1003.005 into x3. It means x3 means the additional shop. If we open additional shop, then sales will increase 1000 units. Okay, so this is about uh, the B coefficient, and the out of the standardized regression coefficient beta tell us the weightage, means the maximum contribution done by the advertising expenses because its value 0.2 0.527. Second important factor discount, and third important factor 1.5 0.6160. This b0 plus b1 x1 plus b2 x2 plus b3 x3. Sometimes our objective may be what are the factors influence the outcome variable and which one is more important. So through this beta coefficient we can say that out of the three independent variables, advertising expenses contributing more to the dependent variable. Now the t value, this is the t value. So t value is this. Whether this independent variable significantly contributing or not. So this p value tell us, and this p value should be less than 0.05. Again, all the three independent variables p value we can see less than 0.05. It means all the three independent variables are significantly contributing to the dependent variable. Then how will we calculate this t value? So t value equal to the b upon se, standard error. And what is the b? This 8.917, and the value of this 1.1.076. So we will get the value 8.290. This is the t value, and t value should be greater than 1.96 plus minus. Okay, if t value minus 3.86, again its p value will be less than 0.05. So this sign doesn't matter, it may be positive or negative, but its value should be high. Okay, so and the another table you can see here, the 95% correlation coefficient. So if both value, lower limit and upper limit, both are positive or same sign, it means the independent variable is significantly contributing to the dependent variable. So again, all the three independent variables, lower and upper limit, same sign. So it doesn't include zero. So there is no issue. So okay. Now these are the correlation, zero order correlation, partial part, and collinearity diagnosis we use in so explaining mm, the assumptions of the multiple regression analysis. So this is about the so now the correlation again. So there are correlation, zero order correlation, and partial correlation. Basically, correlation, zero order correlation means when we are taking all the correlation simultaneously, means all the independent variables simultaneously, and we are uh, seeing the relationship between the two variables. For example, in our study, there are three independent variables. So zero order correlation, here you can see the 0.606. Zero order means we are not controlling any other variable. And here in a partial correlation, we are controlling the impact of the other two other variables. Okay, so here the in the second independent variable, the zero order correlation 0.65, and partial correlation, this is the this controlling the effect of the other variables. And this is again the part correlation. Also you can see the correlation between the dependent and independent variable when the linear effect of the other independent variable in the model have been removed, then this indicate it related to change in R square when variable is added to the equation, sometimes called the semi partial correlation. So basically in a zero order correlation, we do not control any independent variables. In a partial and part correlation, we control the independent variables. Now this is about the uh, output of multiple correlation regression. We we take the assumptions of multiple regression analysis. So basically there are main 5 assumptions of multiple regression analysis. First assumption is linearity. So I am explaining one by one. Please, linearity. Okay. So basically 5 assumptions of multiple regression analysis. First assumption, linearity. Then second, homoscedasticity or constant variance of the error term. Third, third assumption of the multiple regression analysis, independence of the error terms. So we find through the Durbin-Watson test. And fourth is normality test. And fifth is multi-collinearity. So first of all, I am taking first assumption, linearity, whether our data linear or not. Now what does that mean? So first assumptions, I am explaining the assumption 1. So in the assumption 1, here we are taking the 3 independent variables like b1 x1, b2 x2 plus b3 x3. Okay. Now the partial correlation, the linear relationship, the dependent and independent variable. This is dependent variable y, x1 independent variable. The relationship between the dependent and independent variable should be linear. It means this advertising budget, that is x1, and y, this is sales. Okay, sales. The relationship between the two variables should be linear. So here we can see the data dispersiveness of the data, it is linear. It is not taking any shape or curve. So it is linear. So here we will find linearity of the 3 independent variable. First data, it is linear. Now we check the linearity of the other variable. Second variable, that is second independent variable, discount. Okay. So here the again there is a positive correlation between the discount on products and sales. If it takes the shape of like this is non देखिए, our data should be always in a linear. So if our data not linear, we cannot use multiple regression analysis, but we take some special case. So for non-linear data, so we use a special type of multiple regression analysis. So this should not, our relationship between the two variables should not be like this. It is non-linear relationship, which is not desirable for our study. Okay, so data should be linear. uh, then third variable, this is, it is also more or less linear, not perfectly linear. You can see here, so there is a positive relationship. So as we increase the number of outlets or shops, sales will increase. Okay, this is the first assumption. Now I am taking second assumption. Second assumptions means constant variance of the error term. So constant variance of the error terms, this is the yes, this one is the constant variance of the error term. So the dispersiveness of the residuals more or less same above or below the zero line point. So I am drawing the line, then apply second 2. I'm just drawing it, and third is minus minus. Then close. Now you can see this graph. I'm just putting another line. 2 and close. Okay, now you can see this graph. So here in this graph, for this is second assumption of the multiple regression analysis. This is constant variance of the error term or homoscedasticity. This is the homoscedasticity. This is our zero line. Okay, this is zero line. So all the observations above or below in, if it is deviate uh, from this line, zero line, above +2, then in a below it will be -2 also. It means only the one observation it is deviate much from this zero line. Okay, so if dispersiveness of the data in range is same, constant across the observations, different observations, then it means there is no issue of homoscedasticity. So through this graph we can say there is no issue of uh, homoscedasticity. And the third assumption of the multiple regression analysis, that is the independence of the error term. Independence means the observation of one respondent should be independent to another. So through Durbin Watson test, this. Okay, so now you can see the value of Durbin Watson test. Here its value, it is 1 point. Durbin Watson test value 1.697. It is desirable, and its value vary from means its value should be 1.5 to 2.5. If it is between this, then we can say there is no issue of independence of the error term. Okay, now the fourth assumption, that is normality. Related to normality, yes, this is the normality, uh, whether the error term normality means the observed and estimated, difference between the observed and estimated. So this is the data should be normally distributed, means in a bell shape. So it is more or less in a bell shape. Okay, so there is no issue of normality also. If it takes the shape of skew, means positively skewed or negatively skewed, then we can say it's a violation of assumption of multiple regression analysis. Data not normally distributed. Okay, so it is in a bell shape, so there is no issue of the normality of the data. And second graph, another, that is pp plot. And pp plot, this is the pp plot. So again through this plot, pp means probability plot. Through this plot we can uh, say that whether our data normal distributed or not. So here you can see the all the observation more or less on this diagonal. Okay, if it is deviate from this, like if my observation like this, means deviate from this line, then I would say there is data is not normal. But all the it is more or less on the diagonal, so there is no issue of the normality of the data. And another is the multi-collinearity. Okay, so our data Means multicollinearity means when we take more than two independent variables, so there is issue of multicollinearity. Okay, so multicollinearity means ki each independent variables unrelated to each other. Unrelated means there should be zero correlation, but it is not possible, but there is some limit. So what is the limit? Limit is VIF and VIF and tolerance. So there is the term here, you can see VIF. Okay, so VIF means variance inflated factor. Its value, all the values of the VIF are less than 10, means the VIF value should less than 10. So here you can, we can see this is, it is less than 10, less than 10. In the third model, less than 10, less than 10, less than 10. Okay, and tolerance value, another term, tolerance, it is reciprocal of VIF. Okay, so its value, tolerance value should be greater than tolerance value uh, greater than point 0.1. Okay, point 0.1. So here it is greater than point 0.1, greater than point 0.1, greater than point 0.1. So it means there is no issue of the multicollinearity. Okay. So the this is okay. So this is about the assumptions of the multiple regression analysis. Now I take the another case study, or I will explain quickly that. So I am stopping this side, this slide. So here, how to normality test on SPSS, multiple correlation also tell us about multiple correlation, also tell about the, yes. So multiple correlation means if a correlation highly correlated, the independent variables, then we can say they are the issue of multicollinearity. How, sir, how to do normality test on SPSS? देखिए, your question how to do the normality test in SPSS, or if we are using individual variables, if we want to find the normality of the individual variables, then there are three methods to find the normality of the SPSS. One is through graph, we can check the normality of the data through value of skewness and kurtosis, its value between the -1 to +1. And third method is KS test or Shapiro test. Through KS test or Shapiro test, we can check the normality of the data, and p value should be greater than 0.05. It should be non-significant for normality and homogeneity. So through KS test, we can check the normality of the data. Leaven test, we can check the homogeneity of the data, and both the variables p value should be greater than 0.05. Okay. So another question is, data is not linear, which special method to apply? So you can go through the one book, Hare and Anderson. Okay, some special cases you can see if your data is not normally distributed. So there is one way to normal your data, if data is not linear. So it's a special case. So you can go through the book Hare and Anderson. So you can do this. And what is part correlation. Part correlation, basically, I told you, I am again explaining you part correlation. It is the correlation between the dependent and independent variables when the linear effects of the independent variables in the models have been removed. When we remove the linear effects of the other independent variables, then we find the part correlation. I am again repeating, the correlation between the dependent and independent variables when the linear effects of the other independent variables in the model have been removed. Okay, so yes, if any regression, if any assumption of the multiple regression are not met, then what is the option? So basically, sometimes what happen, if our data, we if data is not right, so for example, there is issue of multi-quality. This is the assumption of the multiple regression analysis. So if highly related independent variables, so we should remove these independent variables and take another independent variable. So best way to go through the literature review before applying the multiple regression analysis, we should take the standardized questions. If we take the standardized questions or scale, then there uh, will not be the problem. Okay, so another question, data not linear, I told you. What does independence, uh, the independence of the error term, I earlier told, the independence of the error term means the data should be unrelated. For example, in a time series data, means I have data of 365 days, so each day's error term will be there. So the day 1 error term unrelated to the day 2 data, day 2 error term unrelated to the day 3, day 4. So this is the concept of error term. Generally, it's a issue of autocorrelation when we take the data of time series, specifically the we this term used in econometrics. Okay, so error term basically it's a difference of the observed and estimated, and this error term should be unrelated to the other observations. And any questions? What the independent p value हो गया, biserial I have explained. Why are we using zero order in partial? So actually, why are we using zero order in partial correlation? Your question is this. So I used zero order uh, correlation for just compare the partial correlation. Although there is no need to use the zero order correlation, I just explain the difference between the zero order correlation and partial correlation. When we take a zero order correlation, the correlation between the two variables value high, and in case of the partial correlation, value was less. So I think almost questions तो सारे हो गए हैं लगभग. So
So one or two questions are left.
कौन से हैं questions?
So the question is, we should always consider standardized coefficient or unstandardized value or both,
हाँ,
right?
ओके. देखिए, हाँ, we should always consider standardized coefficient और unstandardized value और both. देखिए, so इसमें क्या करते हैं कि when we present our model, if we are writing the research paper or thesis, then we should report the unstandardized regression coefficient. Okay, unstandardized regression coefficient, and we should report also standardized regression coefficient. So standardized regression coefficient tell us which particular independent variable highly related with the dependent variable. Okay, but for model purpose, when we are taking or framing the final model, we use unstandardized regression coefficient. And another at ये हो गया question, stability of model and model fit. No, model fit basically stability is something different, so it is not related to the this. Model fit means ki whatever independent variables you are taking in your study, all the independent variables should be statistically significant होना चाहिए, सारे independent variables.
So the next question is, at what level we can say multicollinearity exists?
देखिए, yes, so if value is I told you again, I can show you the screen, the multicollinearity issue. Hmm, multiple regression analysis, yes. So this is such design, so it's VIF value, oh sorry, so the VIF value, I told you the VIF value should be less than 10. If its value less than 10, or and tolerance value point means above zero point 0.9, so it is desirable. So we when we apply the multiple regression analysis for checking the multi-quality, we see the value of VIF. It should be less than 10. If it is less than 10, then it is okay. If it is outside the 10, then we should remove this particular independent variable and add another variables. Okay, thank you very much.
So just a second.
Yes. Namaskar, sir.
Namaskar, sir. Namaskar, sir. Uh, is my I'm seeing.
Yes, yes, yes.
Now,
I
audible,
I
audible.
can see. Yeah,
Yeah,
you are audible.
sir. It's been wonderful listening to you. You know, you're really passionate about your subject. No, I could see the rhythm in which you started, and even at the end, also, I could see you still have a lot of energy to spare. And also, we are very happy that you could take the question by yourself, and which actually it's a very tough job, which we find it, to communicate with the resource person and get back things like that. So it really went well.
Thank, thank you,
Um,
sir.
I hope the participants might also have really enjoyed, listening you. I know I've been all throughout the day, listening you, and you have actually taken us from a simple level to a very basic, complex, or very higher levels. That's really wonderful about your lecture, and as well as I hope it might have catered all sections of our participants. I liked it, sir, and hope even tomorrow's lecture would be the same like this, and
Thank
we'll
you.
how to listen. Uh, uh, I would request all participants to join on time tomorrow at 9:30. We'll see. Thanks a lot, sir. Thanks a lot.
Thank you, sir. Thank you, sir. Thank you.
Bye, bye.
Bye.
Stop live, Ravi.
जी सर, should I live stop the live, sir?
Yeah, you can stop the live.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
Parul ma'am.
Parul,
Parul ma'am.
Sir,
Ma'am, please make me host.
हवा दे दो मेरे को
रवि सर, रवि सर,
जी मैम.
मोर में जाके कौन सा ऑप्शन, अच्छा मेक होस्ट,
Make
ठीक है रवि
host
सर.
ma'am.